Good morning, grade 11s. It's bright and early on a Saturday morning, and I realized that my last video did not record my screen. Great. Yes, I'm having coffee. Okay, and I'm going to be checking to make sure that my screen's recording. So hopefully 7.1 Stoic. Let's see. Okay, it's showing up. Hopefully it works. All right, so let's look at number 11. I know that these questions you guys are all asking me for help with, so I have no problem making sure you guys get through this. Okay, so we have ammonium sulfate and sodium hydroxide. This is a double displacement reaction with further decomposition, okay, because we have that ammonium hydroxide being formed. So just writing it out. Now with stoichiometry, I'm going to teach you the main reason I'm not just posting the answers is I have to teach you guys how to make this table. You do not have to do it this way. You can just do it mathematically, equations going down, whatnot. But this is the way that I really prefer to do everything. Okay. What's given to us is setting this up. We're going to have mass, then we're going to have molar mass, then we're going to have number of moles, and then we have this xn, where this is where you account for the coefficients of that are found in the balanced chemical equation. Okay, the beauty is when you go down the table, you divide. And when you go up the table, you multiply by the numbers. Okay, and we'll go through it and you can see not all the tables that I use are like this, but for stoichiometry, this one is. So the information that's given is that you have 15.4 grams of ammonium sulfate. That's the only piece of information. And what you want to find out is what mass of sodium hydroxide you require. So what piece of information can you get just from looking at the balanced chemical equation that we can use to fill in this table? Hopefully you're thinking of molar mass. And seeing as this is my second time doing this within 24 hours, I have all these ready to go. Okay, so when I was talking about how when you go down the table you divide, what I mean is to get my number of moles of ammonium sulfate, I'm going to divide 15.4 grams by 132.17. It's like this is the denominator, the fraction. So when you do that, you get 0.11652 moles. And see how I'm using many significant digits, I'm leaving many digits. I'm not going to reduce to the number of significant digits until the very end, okay? We don't want to round it to the very end. Okay, so from 15.4 grams, I have 0.11652 moles of ammonium sulfate. My coefficient here is 1. So when I go to this last step here, is xn, you always divide or multiply, depends on which way you're going, up or down, by your coefficients in your balanced chemical equation. Coffee still hasn't kicked in. Okay, this number here, oh, I should check. Is it recording? Yes, it's recording. This number here, it gets carried over here. And now we start going up. So because we start going up, we multiply. I'm going to multiply by 2 because that's the that's the coefficient. So 0.11652 times 2 is 0.23303 moles. So this is important because what it's showing is that you notice how, I'm going to highlight 2 numbers. I need 0.2303 moles of sodium hydroxide for 0.11652 moles of ammonium sulfate. The reason why the numbers are different is because the ratio for the chemical equation is for every 1 ammonium sulfate, you require 2 sodium hydroxide. So it makes sense that you need double the amount of sodium hydroxide for the reaction to proceed. And that's how stoichiometry is. It's basically like baking. If you need 2 cups, or if you need 2 eggs for 2 cups of flour, then you need 6 eggs for 6 cups of flour. I've been doing a lot of baking. Okay, these ones, it's just requiring a lot more information, obviously. Okay, so again, since we're going up, we're going to find the mass, we're going to multiply 0.23303 by 40. And I get 9.32 grams. So do you see there's a big discrepancy? Even though you need double the amount of sodium hydroxide, you require 9.32 grams of sodium hydroxide, whereas half the amount in terms of moles of ammonium sulfate is 15.4 grams. And it's because this formula unit is just so much heavier. Don't look at grams as a scale. You have to look at moles. Do you notice how there's only 3 significant digits? Because in my original number, again, this one I'm circling, 15.4, there's only 3 significant digits. So therefore, 9.32 grams of sodium hydroxide is required. Okay, let's see. I'm not going to do all the questions for you. So from 11, 12, and 13, they're very similar to this 11, and I want you guys to figure those out on your own. You know that there is the answers at the end of the chapter, not at the back of the book. Okay, moving on to question 19. So I don't have the questions in front of me, but I think I can remember them. So this one is about sodium azide, which is what you find in airbags. So this is the balanced chemical equation. You can see that it's a 2 to 3 to 2 ratio. So sodium azide is a solid. If you ever are involved in a car accident, hopefully you never will, but you'll never have to use airbags. But if you ever see them, when an airbag is deployed, there's all this powder that gets released, and that's the sodium azide. And as soon it's an exothermic reaction, lots of heat's given off. That's why you can get airbag burn, but you get production of lots of sodium gas, which inflates the airbag. Okay, so let's start. Mass, molar mass, number of moles accounted for with coefficient. We are given that, what is it? You need to produce 80.0 grams of nitrogen. Okay, so that's the only piece of information that's given. Well, obviously, from the periodic table, we can fill out the molar mass. So nitrogen is 28.02. Sodium azide is 65.02 grams per mole. Okay, so this is how I always set up my questions before I do anything else. I have what has been given to me, so the mass, and then I'm filling out my molar mass off the periodic table. Okay, so moving downwards, I'm dividing. So 80 divided by 28.02 is 2.8551 moles. And then, what am I dividing here again for xn? I'm dividing by the coefficient. And the coefficient for for nitrogen, I'm going to be dividing by 3. So 0.9518 mole. So then when you carry this number over, so see how I'm carrying over the 0.9518 mole. That is the most important number, but it's the most useless number unless you have a coefficient of 1. It's basically, it's what's scaling the chemical equation proportionally, but the only way that you can find any real numbers is by multiplying it by the coefficient. So for here, 0.9518, it's not useful to me for sodium azide because I have a coefficient 2, so I multiply it by 2. So now I know this number is finally important. This number is finally real, 1.9034 mole. What that represents is if I want to produce 80 grams of nitrogen gas, I have to have 1.9034 moles of sodium azide. Now, moles are nothing to you, right? You can't quantify them. So we're going to multiply it by the molar mass, and I get 124 grams. That is very understandable for you. If I said go and get 124 grams of something, you get an electronic balance, you'd weigh it out, and just think about the calculation that we just did. We said we require 80 grams of of nitrogen gas to be deployed in our airbag. We did the calculations, and now we know in that airbag we have to put 124 grams of sodium azide. Okay, B still requires this question. I think it's how many moles or how many atoms of sodium are produced as well. I already did most of the work. I already know I have this number here. Remember, this is everything to scale, not regarding the coefficient. So the first thing I have to do is multiply by 2. So now I know that 1.9036 moles of sodium are produced from this decomposition. That's not what the question is asking. It's asking for number of atoms. So I'm going to go N equals number of moles times Avogadro's number, 1.9036 moles times 6.02 times 10 to the 23. Now you're probably thinking, why is Ms. Vella doing it like this? I'm doing atoms per mole because that's the unit for Avogadro's number in this case. And I love unit conversion, which is you get rid of the units. And so now I can cross out, I know for certain that I'm calculating the number of atoms. 1.15 times 10 to the 24 atoms of sodium. And if you practice unit conversion, if you practice canceling out units to find out what you want, then that's how I got through not having to memorize formulas in physics and chemistry. Okay, so it's good, it's useful to have. All right, those are the only 2 questions that I'm going to give you guys for 7.1 stoichiometry. Again, I said this in my first video, if there's anything in grade 11 that you have to take away from this course, it is stoichiometry. We really need you guys to understand this. So you guys are impressing me. You guys are going above and beyond. I can tell that you guys want to learn. And I'm really thankful, and you guys are motivating me. With that being said, if you don't understand this, make sure you understand it before moving on. You will do this for the rest of your chemistry career, whether you're done after this year, whether you're continuing on to university, you will have stoichiometry forever, okay? And you'll do these, it's going to be expected that you know how to do this from the beginning of grade 12. Okay, that's enough pep talk from me. I hope this works. If not, I'm going to have to do it again. All right, take care, and thank you guys for letting me know it didn't work.